Hello students, myself Jyoti Kiran, Assistant Professor, Government First Grade College, Tiptur. Now I am going to explain row reduced echelon form. First we move on to the definition of row reduced echelon form, or it is called as a row canonical form. A non-zero matrix A of order m cross n is said to be a row reduced echelon form if it satisfies the following condition. The first non-zero entry in each non-zero row is unity. It is called the leading entry of the row. All the entries below the leading entry are zeros. That is, the column containing the leading entry of any row has all other entries 0. The number of zeros appearing before the leading entry in each row must be greater than the number of zeros appearing in its previous row. The non-zero rows appear at the top and the rows with only zeros appear at the bottom of the matrix. Thus, the number of non-zero rows of a row reduced echelon form of a given matrix is the rank of the given matrix. If there are r number of non-zero rows in the echelon form or row reduced echelon form, then R is the rank of the given matrix. In the example, the following are the row reduced echelon form of the matrices whose pivots have been circled. So here these are the pivots. So then we have to, in the next example, these two are the pivots. Here these two are the pivots. Next below the these diagonals, all the elements are zeros. Okay, next procedure to obtain row reduced echelon form. So first we look at the first column of the given matrix. If the first entry in the first column is 0, then we interchange the first row with some other row so as to make the top entry in the first column is non-zero. Next step, perform suitable row operations from the remaining rows to make all the entries in the first column 0 and make the non-zero top entry in the first column as unity. Repeat the above two steps starting with the second element in the second row to make all the elements in that column 0. Continue the transformation in this process for the entire row. The above steps reduces the given matrix to the row reduced echelon form. Finally, if there are r number of non-zero rows in the row reduced echelon form, then R is the rank of the given matrix. Use elementary transformation, reduce the following matrix to row reduced echelon form or row canonical form and hence determine their rank. So in this example, first we have to operate row operations. Here R2 dash, second row. Below this unique element, we have to make the below this element, pivot element, we have to make all the elements are zeros. For that we have to operate R2 dash is R2 minus 2 R1, R3 dash is R3 minus R1 and R4 dash. So this is fourth row, R4 dash is R4 plus R1. Then this matrix is equivalent to A equivalent to, after applying these elements, all the elements are zeros below this pivot element. Then once again apply the row operation, R3 dash is R3 minus R2, then R4 dash is R4 minus R2. We get this equivalent matrices. Okay, again we have to operate the row operations. Then R2 dash, second row, R2 dash is R2 1 by 5 R2, then R3 dash is 5 R3 plus R2. We get the one more equivalent matrices. Once again for this matrix operate R3 dash, third row, R3 dash 1 by 16 R3, here 16 is there, divide 1 by 16 R3, then R4 dash is 16 R4 minus R3. Finally, we get this matrix. In this matrix, there are 3 non-zero rows and 1 zero rows. For this, the rank of the matrix is 3. Next, we move on to the example 5. Here we have the matrix of order 3 cross 3. Operate the row operation R2 dash and R3 dash. R2 dash is R2 minus R1 and R3 dash is R3 minus R2. We get the equivalent matrix. For this matrix, again operate the row operation R2 dash is 2R2 minus R1 and R3 dash is R3 minus 2R2. We get A equivalent this matrix. In this matrix, all the elements in the third row 0. Okay, once again operate the row operation. R1 dash is 1 by 2 R1 and R2 dash is 1 by 7 R2. We get this matrix. Finally, this is A equivalent to the matrix. In this matrix, in the last row are zeros. There are 2 non-zero rows. For that reason, the rank of a matrix is 2. Next, we move on to the example 3. Here the matrix A of order 4 cross 4. For this matrix, operate the elementary row operation R2 dash, second row, R2 minus 2 R1, R3 dash is R3 plus R1 and R4 dash is R4 minus R2. Below this leading element, this element must be 0. Okay, so the first operation, these elements, all the elements are zeros. Below the element 1. Then once again operate third row operations. R3 dash is R3 plus R2 and R4 dash is R4 minus R3. Then we get the next equivalent matrices. For this equivalent matrix, once again operate R4 dash. R4 dash is equal to 1 by 8 R3 and R4 dash is 1 by 33. Okay. Then we get 1 by 33 into R3. We get this equivalent matrix. Here there are 4 non-zero rows. For that reason, the rank of a matrix is 4. Next, we move on to the example 7. So, in this example 7 also, we are going to operate the elementary row operations. Here R2 dash is R2 plus R1, R3 dash is R3 minus R2 and R4 dash is R4 minus R3. After applying these elementary row operation, we get equivalent matrix. For this equivalent matrix, again operate the row operations. That means below the principal diagonal elements, make it 0. For that, we have to apply once again the row operations. Then we get the equivalent matrix. In this matrix, the last row, all the elements become 0. Again, we have to once again operate the third row operations. R3 dash is 5 R3 minus R2. Then we get this final equivalent matrix. In this equivalent matrix, the last row becomes 0. There are 3 non-zero rows. For that reason, the rank of a matrix is 3. So next we move on to the example 8. Here also we have the square matrix of order m cross m of order 4 cross 4. Here interchange R1 to R2. We make the pivot element must be unity. Then we operate the row operations. R2 dash is R2 minus 2 R1 and R3 dash. R3 to R1 interchange. Then we get this equivalent matrix. For this equivalent matrix, again apply the row operations. This row operations. After applying this row operation, we get finally equivalent matrix having the fourth row is 0. So which is a row reduced to echelon form having 3 non-zero rows. So below the principal diagonal elements, the elements are zeros. Else the rank of a matrix is 3. There are 3 non-zero rows and below the principal diagonal elements are zeros. So next we move on to the example 9. So here also we have to make the first pivot element must be unity. For that interchange R1 to R3. Then we get this equivalent matrix. Then operate the elementary row operation. R2 dash is R2 minus 2 R1 and R4 dash is R4 minus 4 R1. We get this equivalent matrices. For these matrices, again operate this operation. So our aim is to below the principal diagonal elements, all the elements must be 0. For that, once again we have to operate the fourth row. We have to make this element 0. For that reason, R4 dash is 5R4 plus R3. So next matrix is all the last row elements is zeros and below the principal elements are zeros. Hence, this is the final matrix. Hence, which is in the row reduced echelon form and having 3 non-zero rows. Hence, the rank of a matrix is 3. Thank you.